Now let's think about the line of best fit in a little bit more detail. Another name for it is the least squares regression line. And the reason that it's called that is because the line of best fit minimises the squared distance between each data point and the line. Now that makes sense if you consider that some of the distances between the data point and the line will be negative and some will be positive. And so if you were just going to find the average of all those distances and minimise it, make that distance as small as possible, the fact that some are positive and some are negative sort of messes things up. So if we square each of the distances, it gives us a range of positive numbers, which we can then average and minimise. Now you can work that out by hand, but that's not something that you need to do in this course. You can also use technology like graphing software to come up with this line of best fit, or you can actually just draw it by eye. I've just drawn this one in by eye, and I've roughly reasoned that I need to put the line so that roughly half of the dots are above or below, but also I've tried to sort of minimise or average out the distance between each dot and the line. Now, what do we do with our line of best fit? Well, we can use the gradient of it to kind of analyse the association. In other words, if the gradient of this is positive, I can see that as the x values go up, the y values are expected to go up. We can also see if they're going up sharply or not so sharply based on what the actual number of the gradient is, not just the sign of it. But the other thing we really use the line of best fit for is so that we can predict values of y for possible values of x that we might be interested in. And there's two different ways we can do this. Now, you might know this word, but not this one. If I say, can you please extrapolate on that for me, I generally mean, can you go on a little bit more about it so that I can understand what happens next or what happens further to that. Interpolating, a little bit different. Now, extra means outside and inter means inside. So if we extrapolate, it means to describe something further, doesn't it? And it's the same in maths. So if I had data here that was, say, something like height and weight, and we know that as people get taller, they generally get heavier, then if I wanted to extrapolate, that would be finding an estimate, I suppose, for the weight of someone who's maybe this height. I could draw this line out further, and I could say, well, if I've got somebody who's this height, perhaps they're going to be this weight. Now, it's clearly an estimate. They might not be. Clearly, most of these people are actually not on the line. But it gives me some sort of idea what height and weight might go together. Now, this could be quite inaccurate because I've got data points in this area here. I haven't measured anybody who's this tall or this heavy. So I'm not sure if the association holds true up there. So you have to be very careful when extrapolating because you're taking your line of best fit into an area of the unknown. And you can't be as sure that things are going to work the way you expect in that area. Interpolating is estimating a value in a range that you have a bit more confidence in because it's somewhere in the data points that you already have. I could go up and across and say this is a decent estimate, and this would be interpolating with my data because I'm working within the constraints of data points I already have. Now, to find the line of best fit using your calculator, let's use the data that we just saw for finding Pearson's correlation coefficient, or R, with that height and weight data, those imaginary 5 people. All you need to do is follow the exact same process, and we've already put our data into the calculator. But remember that we selected for regression analysis bx plus a, and I said that reminds you of a straight line, doesn't it? Because it looks like y equals mx plus b. And it was actually written around the other way. It was written a plus bx on the calculator, but same thing. Now, if you have a line in this form, b will be the gradient and a will be the y-intercept. So all we really need to do to get the equation of that line of best fit that goes with our data points is to find out what b and a are. So to do this, we will go into our Shift 1, that's our stat retrieval mode, select 5 again for regression, Now this time, we don't want 3, which is R, we want 1, which is A, and 2, which is B. So literally press 1 equals, and it'll tell you that A, in this case, or our y-intercept is minus 39. Let's jot that down. This is minus 39 or so, rounding it off. And now you have to go out of there and hit Shift 1 to get back in again, choose regression all over again. And then this time we'll choose 2 for B. That's going to be our gradient, and let's round that off to 0.6. Now, what does this mean and what would it look like? Does it make any sense? Well, we had people of various heights and weights, didn't we? And the heights didn't really start till we were up to 170 or something like that. No, 150 I think was the shortest person, and we went up to 170. So if we were graphing this, we might have data points that are, way up here, like something like this. Okay, so it's not really nicely spread out if you have 0, 0 as the origin. That's the first thing. Now a gradient of 0.6, what does that look like? Well, 0.6, that's 6/10, which is also 3/5. That would look roughly like this. Okay, does that sort of make sense? Yeah, that seems fine. So we've got a line that is y equals m, gradient of 0.6, let's call it 3/5, or you can actually put your 0.6 in there, x, plus negative 39. Well, let's just write minus 39, and I rounded that off to the nearest whole number. Now that means a y-intercept of minus 39, which will be down here somewhere. So I could graph this starting on minus 39 and then drawing in a gradient of 0.6, and I'd have my line of best fit. Obviously, part of the line doesn't make a lot of sense to the question. You can't have a negative height. But notionally, this is the line of best fit. It's the equation of it up here where we're interested. And of course, you could always zoom into the graph and really just be graphing this part of it. But now you have the equation of that line of best fit.